Orthodontic treatment involves gathering records to be able to formulate a treatment plan and establish the details needed for a patient's successful completion. The records that we commonly use include study models, x-rays, and photographs. Study models, we've historically used impression materials that goop in the mouth stuff that we use to create a casting of the teeth in their current position, and then that casting is then poured up to make a model, usually with a hard stone. These days, image gathering is different for models in that an intraoral scanner is commonly used to make them models. It utilizes sophisticated white light scanning that will create thousands of photographs with topographical information that is knit together to then make a file of the topography of the teeth. This is an example of teeth that have been electronically rendered into a map for a patient. And with software like this, we can manipulate teeth one tooth at a time and make movements that allow us to develop a treatment plan. What you're seeing is the resultant conflicts or spacing that's created as a tooth is moved in this case, rotated. This is now flaring out the tooth, just demonstrating how these changes affect what position this tooth is in relationship to its adjacent teeth and how that would affect the bite or the occlusion. Additionally, you have to keep in mind how this tooth and what you don't see is the projection of this root actually relate to the bony surrounding. But through this process of tooth manipulation, we can create a treatment plan that will move a tooth in a desired direction. When that treatment plan is finished, the software cuts up all the needed movements into little bite size for each aligner to be able to accomplish its small goal of 2 to 3/10 of a millimeter movement. And then it will then generate how many steps or aligners are needed to accomplish your desired tooth movement. Another piece of technology to help move teeth in the world of orthodontics is this one, which utilizes a scanned image, intraoral scanned image. The teeth are moved to a final position that is desired, and then a robot literally goes in and bends this wire to achieve all these movements in all 3 dimensions. And here is the list of displacements, or how each tooth is moved and in what direction for both. This is the upper and then the lower to achieve the result. But the robot bends this wire, and I select a wire chemistry and thickness that will facilitate the safe movement, but over a series of a few wires, be able to move these teeth to the desired finish line. And so this gives us a more efficient expression of orthodontic treatment, and much like if conventional orthodontic treatment is regular mail, this efficiency is more like expedited mail to efficiently get teeth moved to a finish line. Orthodontics has benefited from many technological advancements. This process you're observing is teeth and braces that have been scanned, and teeth that have been moved then to a finish line from a from a previous position or starting position to then a finished position. And the wire is then made by a robot to deliver all these specific detailed movements in an efficient and effective way to help reduce by 30 to 40% the treatment time for patients. We still need to be choosing wire alloys and dimensions that keep these movements in a safe, healthy process, but the efficiency in time is just by having the treatment plan developed in the wire.